This shift from Einstein's static curvature to Koecki's dynamic expanse fundamentally redefines celestial mechanics. In this model, the gravity well is revealed to be a geometric illusion caused by the two-point expanse ratio. 1. The collapse of the gravity well. Einstein viewed gravity as a dip or curvature in a fabric. However, if space is a propagating stage with a 2.1 expanse ratio, the well disappears. The expanse pressure, the 2.1 ratio, represents a constant outward mechanical expansion of the grid itself. Linear alignment. Because the grid expands at this specific ratio, it creates a swing or motion ratio. This pressure is so consistent and powerful that it forces the planets into a straight line roll, the ecliptic plane, relative to the sun's geodesic. No dip needed. Instead of falling into a hole, planets are being held in a stable, pressurized path by the expansion of the grid. 2. The 2C pressure barrier. The most critical change to Einstein's geometry is the planetary pressure at 2C. Dissociation. Because the expansion and the celestial motion create a cumulative pressure of 2C, the planets effectively dissociate from the kinetic grid. Direct connection. This high velocity pressure pushes away any direct friction with the grid nodes. The result, planets don't drag space or warp it. They float within the pressure gradient created by the 2-1 expanse. Gravity is no longer a well, but a result of the pressure differential between the planet's mass and the surrounding 2C grid expansion. 3. Traveling the sun's geodesic. When Earth travels along the sun's geodesic, its relationship to the grid remains arbitrary and constant. Inertial stability. Because Earth is locked into the 2-1 expanse ratio, it maintains its position in the straight line roll without needing to climb out of a gravity well. Massless influence. Since the nodes themselves are massless, the sun's geodesic is simply the path of least resistance within the 2C pressure field. Summary, geometry comparison, and by replacing the well with expanse pressure, the model simplifies celestial mechanics. Planets don't stay in orbit because they are falling. They stay in orbit because the 2-1 ratio creates a mechanical track that they cannot leave without overcoming the 2C pressure of the stage itself. Have you ever seen that classic image of gravity? It's a bowling ball sitting on a rubber sheet. The ball makes a dip. Little marbles roll down into it. That's supposed to be how gravity works. The sun makes a big dip and Earth rolls around inside it. But what if it's wrong? What if the universe isn't a static sheet you can dent? What if it's more like a flowing river, a dynamic moving grid that carries everything with it? The fabric of space-time isn't just sitting there, it's expanding. For every 2 units of space created, 1 unit of time is created, a 2-to-1 flow. This 2-to-1 flow changes everything. The background is active, a kinetic grid, constantly growing and flowing. Imagine the universe as a vast, invisible river rushing outward. Planets, stars, galaxies, they aren't just sitting in the water, they are part of the flow, carried by the current of space-time. This isn't just a different picture, it's a different kind of physics. The engine of the universe isn't a pull from afar, it's the substance of reality pushing from within. The old bowling ball on a sheet model struggles. You need dark energy to stretch it faster. So how do planets move in this new picture? Forget the idea of Earth constantly falling toward the sun. In the kinetic grid model, planets are rolling along stable channels in the flow of space-time. Think of a log caught in a river eddy. It doesn't sink to the bottom of the river. It finds a stable circular path and stays there. The eddy is a whirlpool, a localized pattern within the larger current. In the same way, a massive object like the sun creates a stable vortex in the expanding grid. It doesn't pull the Earth, and instead the sun's mass organizes the local flow of space-time into a swirling pattern. The Earth, caught in this pattern, simply follows the channel it's in. It's like a race car on a banked track. The car isn't being pulled to the center of the track. It's following the curve of the road itself. The Earth is following the curve of space-time. The beauty of this idea is that the motion doesn't require a constant drain of energy. The planet isn't fighting to escape a well. It is in a state of equilibrium, perfectly balanced within the moving channel. This is what we call dissociation. The motion of the planet is dissociated from the energy of the central star. The Earth is just going with the flow, its own stable cosmic flow. In the old model, you have to perfectly balance forward momentum against the constant pull of gravity. Any little nudge could, over eons, disrupt that balance. But in a channel, the system is self-correcting. If Earth were to drift slightly out of its channel, the currents of the grid would gently guide it back in. The channel itself provides the stability. The orbit isn't a tightrope walk, it's a groove. This inherent stability feels more natural, more in tune with a universe that has sustained these orbital ballets for cosmic ages. So when you look up at the moon or think about the Earth's journey around the sun, change your mental image. Don't see a rock being pulled by an invisible string forever on the verge of falling in or flying away. Instead, see a majestic ship navigating a powerful, invisible river. See the planets as masters of their own currents, settled into stable grooves carved into the very fabric of an expanding reality. They are not prisoners of gravity. They are cosmic surfers riding the waves of space-time with effortless grace, carried along by the fundamental flow of the universe itself. If the universe is expanding, does it have an edge? Where does it end? The kinetic grid offers a mind-bending answer. There isn't a wall or a sign that says end of the universe. Instead, there's a horizon, a propagation horizon. Imagine you're on a speedboat. The water around you is rushing away. There's a point on the horizon where the water ahead flows away faster than your boat can go. You can see that water, but you can never reach it. That's the propagation horizon, the limit of what we can ever interact with. In the kinetic grid model, space itself is being created very quickly at a certain distance. Nothing, not even light, can cross it to reach us. The 2-to-1 flow of the grid, the constant creation of new space and time, builds this barrier naturally. This isn't a physical wall. It's a consequence of the expansion itself. Everything beyond that horizon is, for practical purposes, in a separate universe. We can see the light that left distant galaxies billions of years ago, but we can never visit them. One of the cornerstones of modern cosmology is redshift. When we look at distant galaxies, their light is stretched to longer, redder wavelengths. The standard explanation is the Doppler effect. The galaxies are moving away from us, so the light waves they emit get stretched out. But the kinetic grid suggests something else. It's not that the galaxy is moving through space away from us. It's that the space between us and the galaxy is expanding, and this expansion puts the grid itself under tension. Imagine a guitar string. When you pluck it, it vibrates and creates a sound, a frequency. Now, what happens if you stretch that string while it's still vibrating? The tone goes down, the frequency drops, the wavelength gets longer. In the kinetic grid model, a photon of light traveling across the cosmos is like that vibration on the guitar string. As the photon travels for billions of years, the grid of space-time it's traveling through is constantly expanding. This expansion stretches the grid, creating a kind of tension. This tension causes the photon to lose energy, its frequency to decrease, and its wavelength to get longer. This is a profound shift. Redshift is no longer just a measure of velocity. For decades, we've been mystified by an observation. The expansion of the universe is accelerating. It's speeding up. To explain this, we invented a placeholder name, dark energy. We say it makes up nearly 70% of the universe, but we have no idea what it is. It acts like a kind of anti-gravity, pushing everything apart. It's one of the biggest mysteries in all of science. But what if dark energy isn't a mysterious, exotic energy at all? What if it's just the machinery of the universe doing its thing? In the kinetic grid model, the expansion isn't caused by some strange energy. The expansion is the fundamental process, the 2-to-1 flow. The constant creation of new space-time is the engine. So what we call dark energy is simply the mechanical pressure of the grid itself. Think of it like the pressure inside a tire. You don't need to invent a mysterious dark air to explain why the tire is firm. The pressure comes from the motion of the air molecules inside. If the entire universe is expanding, why isn't our solar system expanding? Why isn't the Earth moving away from the sun? Why isn't your house flying apart? The Standard Model explains this on local scales. Gravity is strong enough to overcome the cosmic expansion. The kinetic grid offers a more elegant answer. It sees massive objects not as things that overcome the expansion, but as things that change the local rate of expansion. A galaxy, a star, a planet acts like a ballast. It dampens the flow. Directly next to the boulder, the current slows down, eddies form, the water might even seem still. The boulder doesn't stop the whole river. It creates a local zone of calm. In the kinetic grid, a galaxy is like that boulder. Its immense mass acts as a ballast, slowing down the local rate of space creation. The galaxy is a quiet harbor in the midst of a rushing cosmic sea. So, yeah, that's why your house stays put. So we have a new picture of the cosmos, a kinetic grid, a 2-to-1 flow, channels for planets, a new take on redshift and dark energy. It sounds nice, but is it science? Science requires testable predictions. An idea is only as good as the questions it allows us to ask. The kinetic grid model leads to simple, clear, testable questions. We don't need a $1 trillion accelerator. We just need to look at the data we already have in a new way. First, a simple question. If redshift is caused by grid tension, does light lose energy smoothly over distance or in tiny discrete steps as the grid stretches one cell at a time? That might show up as noise or quantization in the redshift of the most distant objects. It's subtle, but instruments are getting incredibly precise. We can look for this pattern, analog or digital. The kinetic grid suggests digital. Our fastest ship, a beam of light, can't catch them. That explains why the observable universe has a finite size. The whole universe might be infinite, but our view is not. Our view is limited by the propagation horizon. It's the ultimate cosmic speed limit imposed on space itself. The universe beyond that horizon expands away faster than light. That doesn't violate Einstein. Einstein said nothing in space can travel faster than light. He didn't say space itself couldn't. When we point telescopes outward, we stare at our horizon. We see ghost light from places swept away by the cosmic current. The edge of our universe isn't a place, it's a time. The moment the light began a journey it could barely complete. The kinetic grid says this edge is built into expanding reality. It's the natural shoreline of our cosmic island, defined by the relentless outward flow of space-time itself. It's worth pondering. Redshift is no longer just a measure of velocity, it's a measure of the total amount of grid expansion the light has traveled through. It's a direct measurement of the distance, not in miles, but in the accumulated stretching of space-time. A little bit of redshift means the light traveled through a small amount of expanding grid. A huge redshift means the light has been on an epic journey across a vast, stretching cosmic fabric. The light itself is a probe, telling us how much the universe has grown since that light began its trip. So the next time you see one of those incredible deep field images from the Webb telescope with galaxies appearing as faint red smudges, think of this. You're not just seeing objects that are far away. You are seeing the effect of the cosmic grid itself. The light from those galaxies is tired. It has been stretched and strained by its long journey through an expanding reality. The red color is a scar, a battle wound, earned over billions of years of fighting against the constant tension of a growing universe. It's the universe's own fingerprint, left on every single beam of light. This isn't just a story, it's a hypothesis, a new lens to view the universe. Maybe it's right, maybe it's wrong. The only way to find out is to ask the questions and go look for the answers. That's the heart of the scientific adventure. The universe isn't obliged to make sense to us, but that shouldn't stop us from trying. And this idea gives new places to look and new questions to ask. In science, a good question is often more valuable than an easy answer. Now, let's get to work. Gravity is a difference in flow rate. Planetary motion is a stable pattern in the current. This shift could solve big cosmology mysteries by re-seeing what we already know. It's time to go for a swim in the cosmic river. Right? So let's throw out the old bowling ball. Replace the dented sheet with a vibrant, moving 3D lattice, adding new cells. Dark energy gets treated like a ghost in the math, mysterious everywhere and somehow pushing the universe apart. But what if it's not a ghost at all? What if it's a footprint, or better, tread marks? Imagine space as a physical medium, a kinetic grid, expanding with a built-in 2-1 stretch. Matter isn't floating in emptiness, it's driving through a road that's growing under its wheels. Galaxies are the tires. The grid is the road. The Hubble rate, that's the slow drag forward. When a galaxy plows through this grid, its mass displaces massless nodes. That displacement leaves a wake. Localized changes in pressure and density, those are the tread marks, kinetic scars, and thermal scuffs in the medium. Zoom out to the whole universe. Every star, every galaxy, every cluster is grinding against the 2-1 expanse. The cumulative byproduct of all that friction and displacement is what we've been calling dark energy. Not a standalone fuel, just the mechanical leftovers written into the grid. Einstein pictured space as a passive fabric that curves around mass. Useful, elegant, no road noise, but this model says space fights back a little. High friction interaction, tire meets road, motion creates resistance, and resistance doesn't vanish. It becomes pressure in the grid. We misread that pressure as some separate energy source when it's really the universe's wear and tear report. Now, the paradox Why does dark energy seem to push harder as the universe gets bigger? Mechanically, it's simple. More space means more grid nodes. More nodes means more 2-1 expansion interactions. More interactions means more tread marks, more cumulative pressure. The acceleration isn't a cosmic dial turning up a new force, it's the road getting longer, so the total scuffing goes up. Same tires, more road, bigger footprint. This reframes the whole thing. Dark energy isn't a magic pressure in the void. It's the universe's friction ledger, the mechanical output of matter resisting an expanding stage. Matter isn't separate from the stage. It's coupled to it, shaping and being shaped by the grid. And here's the kicker. If tread marks come from matter pushing through the grid, what happens in the deepest cosmic voids? With almost no tires on the road, does the grid expand in its purest 2-1 form? Clean, efficient, no extra pressure from scuffing? If so, the ghost fades where the traffic thins, and the expanse shows its true, unburdened motion. That's not spooky at all. That's mechanics.